Good morning, ma'am. Today we are here with the presentation for the DA2, and the topic is blockchain. The team members are myself, Mihir Antwal, and my friend here is Methuselah. The table of contents, we'll talk about the introduction first, which will contain blockchain terminologies, distinction between databases and blockchain ledgers. Then we'll move on to cryptographic content. Then we'll talk about consensus components, and finally we'll end with blockchain structures. So let us start with the introduction. First and foremost, we need to go through blockchain terminologies. The famous statement for blockchain goes as, to understand the power of blockchain systems and the things they can do, it is important to distinguish between three things that are commonly muddled up, namely the Bitcoin currency, the specific blockchain that underpins it, and the idea of blockchain in general. That's why it is very important to understand firstly the blockchain terminologies. So moving on to the terminologies, the first terminology is blockchain itself. It is also known as DLT, Distributed Ledger Technology, which is rudimentary shared accounting system. Technologically, it is a distributed database which has public ledger where you can insert, select data, but we cannot update or delete any data. It is a distributed computer which executes digital contracts. It is based on P2P, which is peer-to-peer technology, cryptology, and API. Next is, in fact, the blockchain is more than just a technology. It usually contains financial transactions, is replicated across a number of systems in almost real time, uses cryptography and digital signatures. It can be written by anyone, by everyone in public blockchain, but only certain participants in a private blockchain. It can be read by participants and has mechanisms to make it hard to change historical records.
So coming to distributed ledger. So to understand distributed ledger, we need to understand distributed systems. So understanding distributed system is essential in order to understand blockchain, because basically blockchain at its core is a distributed system. To be more precisely, it's a decentralized distributed system. So the definition of distributed system goes as, distributed systems are a computing paradigm whereby two or more nodes work with each other in a coordinated fashion in order to achieve a common outcome, and it's modeled in such a way that end users see it as a single logical platform. So coming to the ledgers, as we can see on the left side, we have a centralized ledger. So what it does is most companies currently use the centralized ledger or centralized database that lives in a fixed location. And now this centralized database essentially has a single point of failure because everything is stored in a single point and a fixed location, centralized location. Coming to the distributed ledger that is on the right side of the second photo, it's a database that exists across several locations or among multiple participants, and it is generally decentralized to eliminate the need for a central authority or intermediary to process, validate, or authenticate transactions. The records are only ever stored in the ledger when the consensus has been reached by the parties involved. So let's dig deeper into the distributed ledger, how it works. There are basically 7 steps in this distributed ledger. First and foremost, users have to initiate the transactions using their own digital signatures and their identity. Then the users broadcast their transactions to the nodes. Then the nodes began validating each transaction. It can be one node and it can be more than one node. Then the nodes aggregate the validated transactions into blocks, which we are going to understand what a block is. Then these nodes broadcast the blocks to each other. After that, the consensus protocol is used. And the last step is the block reflecting the true state is chained to the prior block. So let's look at what transaction and blocks are. A transaction is a value transfer, and a block is a collection of transactions on the Bitcoin network, which are all gathered into a block that are hashed and added to the Bitcoin. Blockchain, sorry. Coming to the next topic, that is mining. It's the process of solving cryptographic problems, and it uses computing hardware, which also triggers the release of cryptocurrency. For example, if the fact F is in the block 21 and the fact E is in the block 22, then the whole network considers that the fact E is later than the fact F. And also there's another terminology, which are the pending facts. This happens when they are not grouped in a block, then the facts are considered as pending. This is an example. So what happens is the process by which transactions are verified and added to the blockchain is also a part of mining. And by default, a node is not a miner. It is any computer that connects to the blockchain network. So it just receives blocks that have just been mined by other nodes. It is voluntary process to transform a node into a miner. So we have heard about the mining process of Bitcoins. So any node that has been connected to a blockchain is not needed necessarily a mining node. It can be a normal computer. Uh, Also that miners on the network select transactions from pools and then form them into a block. The very important part is that every miner constructs their own block, but multiple miners can select the same transaction, the exact same transaction to be included in their own block. So the next topic is forks. What is a fork? A fork is a creation of an ongoing alternative version of the blockchain. So by creating two blocks simultaneously on different parts of network, so this creates two parallel blockchains where one of the two is the winning blockchain. So when does this happen? There are basically 3 points. First is a block is found at the same time. And second is there's a software incompatibility problem. And there's a split between the group of like, we don't agree with these terms and we don't agree with that terms. So there's basically a split. So the fork helps with that. Now coming to the Bitcoin terminology, there's a going that goes around like what is needed is an electronic payment system based on cryptographic proof instead of trust, allowing any two willing parties to transact directly with each other without the need of a trusted third party. And this led to the rise of Bitcoin. So what a Bitcoin is it's basically a cryptocurrency. It's the first asset based on blockchain. This is the main reason why blockchain has been such a good transaction method and such a good distributed ledger method. And it is used for, like Bitcoin is also used for transaction in various domains, including remittance, speculation, or store of value. This is a block of, this is inside the block of a block, Bitcoin's blockchain. This is one of the block. It contains basically a header, transaction count, and block content. This is how the units of blockchain, like traces of transaction, are in the ledger of a Bitcoin. Now this image depicts the detail of how the money or how the Bitcoin is transformed from one account to another account. As we can see, the Rob is trying to send 0.3 Bitcoin to his friend Laura. These are all the processes that are involved. These are the steps that are involved in the transaction of Bitcoin.
A blockchain is a magic computer that anyone can upload programs to and leave the programs to self-execute, where the current and all the previous states of every program are always quickly visible, and which carries a very strong crypto-economically secured guarantee that programs running on the chain will continue to execute in exactly the way that the blockchain protocol specifies. So coming on to Ethereum, it is a decentralized open source blockchain with smart contract functionality. It was proposed in the late 2013 by Vitalik Buterin, a cryptocurrency researcher. It's a decentralized app platform. It has transaction and smart contract ledgers. It is based on the Ethereum virtual machine, EVM, and the cryptocurrency is called Ether. Now this image, it shows how a traditional contract actually works. Here we can understand it by looking at the image. And the next image shows how smart contracts work. So smart contracts are self-executing contracts with the terms of the agreement between buyer and the seller being directly written into the lines of code. The code and the agreements contained therein exist across a distributed, decentralized blockchain network. Smart contracts permit trusted transactions and guarantees to be carried out among disparate anonymous parties without the need for a centralized authority, legal system, or external enforcement mechanism. They render transactions traceable, transparent, and also irreversible. Now, the distinction between databases and blockchain ledgers. A database running on the World Wide Web is most often using a client-server network architecture. So for a blockchain database, end participant maintains, calculates, and updates new entries into the database. All the nodes together to ensure they're all coming to the same conclusion, providing inbuilt security for the network. So databases have admins and centralized control. Only entities with the right access and right access of database and the entities entitled to read or write can do so. So databases are smart and no history of records and ownership of digital records are there. In blockchains, no one is the admin on it or in charge. So anyone can access blockchain and anyone with right proof of work can write on the blockchain. Blockchains are slow, but there is a history of records and ownership of digital records.
So coming to the second topic, that is cryptographic component. Let's dig deep into it. So we will go through the cryptography, hash functions, and digital signatures. So what is cryptography? The simplest definition will be as it's the encryption and decryption of data. There are mainly two main cryptographic concepts used in Bitcoin. These are hashing and digital signatures. And there are three forms of encryption that are widely used: symmetric cryptography, asymmetric cryptography, and hashing. You can differentiate them in the table. So let's go with the definition of hashing. It's the process of taking an input of any length and turning it into a cryptographic fixed output through a mathematical algorithm. For example, Bitcoin uses SHA-256. Now, coming to digital signatures, these are one of the main aspects of ensuring the security and integrity of the data that is recorded onto a blockchain, a standard part of most blockchain protocols, and it is mainly used for securing transactions and blocks of transactions, transfers of sensitive information, software distribution, contract management, and any other cases where detecting and preventing any external tampering is very important. So this slide and the next three slides explain how the hash, symmetric encryption, and asymmetric encryption work. The hash function always produces a fixed length checksum. For example, the length of the hash of MD5 will always be 32 characters. Symmetric encryption uses the same key for encrypting and decrypting, but asymmetric encryption uses a key for encrypting and another key for decrypting. This is the reason why asymmetric encryption is much more safer than symmetric encryption, and also the reason why it is more often used in the technology, information technology, and also in the blockchain technology. So these are some steps on how the hash and asymmetric encryption works. You can go through it. Now, this diagram presents the structure of a transaction and the lock sets with the user's private keys. So this also shows the interest of cryptography for blockchain, why there is an importance of cryptography in blockchain.
Okay, so let us now move on to the topic consensus components, and we'll be talking about principles and paradigms of distributed systems. So the first is Byzantine fault tolerance, BFT. A Byzantine fault is any fault presenting different symptoms to different observers. A Byzantine failure is the loss of a system service due to a Byzantine fault in systems that requires consensus. The dependability of a fault-tolerant computer system, particularly distributed computing systems, where components may fail and there is imperfect information on whether a component has failed. The objective of BFT is to defend against failures of system components with or without symptoms that prevent other components of the system from reaching an agreement among themselves, where such an agreement is needed for the correct operation of the system, basically. So one example of BFT is the use of Bitcoin. The Bitcoin network works in parallel to generate a blockchain with proof of work, allowing the system to overcome Byzantine failures and reach a coherent global view of the system's state. So we'll talk about blockchain consensus algorithms next. Behind every cryptocurrency, there is a consensus algorithm. So no consensus algorithm is perfect, but they all have their strengths. In the world of crypto, consensus algorithms exist to prevent double spending. So the algorithms are proof of work, POW, which we talked about earlier in the Bitcoin case, proof of stake, POS, delegated proof of stake, DPoS, and proof of burn, POB, practical Byzantine fault tolerant mechanism, BFT, and many more. So next, this is an image which explains the difference between proof of work and proof of stake. It can be understood by looking at the image clearly.
So coming to the fourth topic, that is blockchain structures. So let's go into it. First and foremost, we don't need a client server architecture with name roles. Specifically speaking, there's no admin and there's no like logged client, and there's no anonymous client needed. So uh, welcome to the peer-to-peer architecture with pseudonymous client bearing key pairs. So as we talked about the asymmetric encryption, both have different types of keys, and every single person connected to a node is basically a pseudonymous client. And also each and every node has its own database copy, as we can see here to the diagram. This is one of the data structures that have been used. You can see this is just an example of how the blockchain works. This is previous block, and then we have seen the hash ID of all those. Coming to the blocks of data, now each block is stored in a file, and this chart shows the header of a block containing a mining pool, namely HEO-BTC. Now coming to types of blockchain, there are basically three types of blockchains that have emerged after the Bitcoin introduced blockchain to the world. Public blockchain, private blockchain, or consortium, and consortium or federated blockchain. So public blockchain are those in which there is no one in charge and anyone can participate in reading, writing, auditing the blockchain. For example, Bitcoin, Litecoin, etc. Private blockchain is where it is a private property of an individual or an organization. There is usually one in charge of important things such as reading or writing, or there can be someone we can like selectively give access to read on vice versa. This happens in usually the, for example, like bank chains. And consortium or federated blockchain, more than one person is in charge. A group of companies or representative individuals come together and they can make decisions for the best benefit of the whole network. For example, R3 and EWF. Now we can also run our own private blockchain. We can do that by like editing the code. For example, we can run our custom Ethereum blockchain. We can edit the mining difficulty and updates and assume a lot more parameters. And now some parts of the codes are useless because like cryptocurrencies uses without crypto economics and also without the network effect, a private blockchain is basically useless.
Okay, so now let us look at the existing blockchain applications, the related structure and the architectures. So first we'll start off with ERC20. It was proposed on November 19, 2015 by Fabian Waldsteiger, a technical standard used for smart contracts on the Ethereum blockchain for implementing tokens. It defines a common list of rules that an Ethereum token has to implement, allowing developers to program how the new tokens will function with the Ethereum ecosystem. These rules include how the tokens are transferred between addresses and how data within each token is addressed. More than 142,200 ERC20 token contracts have been added as of November 19, 2018. The next is ERC721, which is a class of unique tokens. It is a free open standard that describes how to build non-fungible or unique tokens on the Ethereum blockchain. While most tokens are fungible, which means every token is the same as every other token, the ERC721 tokens are all unique. It defines a minimum interface a smart contract must implement to allow unique tokens to be managed, owned, and traded. The next is ERC725, which is Ethereum Identity Standard. It is a proposed standard for blockchain-based identity which lives on the Ethereum blockchain. It describes proxy smart contracts that can be controlled by multiple keys and other smart contracts. It can describe humans, groups, objects, and machines. Users should be able to own and manage their identity instead of ceding ownership of the identity to a centralized organizations.
So coming to the conclusion, we have gone through all the topics, including the blockchain terminologies. What is the distinction between databases and blockchain ledgers? We've gone through cryptography, the different types of cryptography, hashing, and digital signatures. And we have also covered up the consensus components, which includes the principles and paradigms of distributed ledgers, and also some of the blockchain consensus algorithms like POW, POS. And then we have gone through the blockchain structures, the types of blockchains, And basically we have covered everything, including how the blockchains work and how it emerged from Bitcoin and how it has a very big impact in the upcoming future of the humankind and in the upcoming future of money transactions. So that's all for DA2, ma'am. Thank you.
Thank you, ma'am.